Okay, so I've got some parallel lines here, and I think you already know what parallel lines are, and you probably know that they have the same slope, but that's what I want to point out right now. Okay, and then perpendicular lines are going to form a right angle. These don't have the same slope. One of the slopes here is positive, one's negative. I can see that just looking at it. These actually have what's called opposite reciprocal slopes. Okay, so easiest way to show you what an opposite reciprocal I think is just with an example. So let's say that the slope of this line is 3/4. Okay, now these are perpendicular lines, so they should have opposite reciprocal slopes. So the opposite reciprocal, opposite means it's going to be the opposite sign, okay, and then reciprocal means you flip the fraction upside down. So 3/4 and -4/3 would be an example of opposite reciprocals. Okay, when you multiply these together, the product is -1, as you get -12 over -12, and that's always going to happen with opposite reciprocals, like 2/3 and -3/2. If you multiply those together, the product is -1. But just change the sign and flip the fraction, and you'll have an opposite reciprocal. Okay. All right, so this first example, let's write an equation in slope-intercept form. So let's make sure we remember what slope-intercept form looks like. That's y equals mx plus b. Okay, so we're going to want our answer in that format. So this format, right? This equation's in slope-intercept form. So our line's going to go through this point to -5, and it's going to be parallel to this line. Okay, so I like to set up my these problems in this particular way. I've got what I call the old line and my new line. So the old line is the line that's given, y equals 3/2 x minus 7. And the new line, that's the one I'm writing the equation for. Okay, so and these are going to be parallel to each other, right? We're told that in the problem. Okay, so what I want to do is use the slope of the old line, and here I can just see that the slope is 3/2. Sometimes you might have to do more work to find that slope, but here it's just evident if you know where to look because it's in slope-intercept form. Okay, so that means, hey, parallel lines have the same slope, so now I know that my new line is also going to have a slope of 3/2. Okay. And then what else do I know about the new line? Well, I know the new line is going to go through the point to -5. Okay? So I'm thinking, okay, I know this is going to be y equals 3/2 x plus something. I just need to figure out what that something is. I don't know the b yet, but I can find that. I'm going to find b now. So what I'm going to do is take y equals mx plus b, and I'm going to substitute in the slope. I know the slope is going to be 3/2. Okay, but then I'm also going to substitute in this xy pair. Okay, so I'm going to put, I'm going to substitute this in as well into this equation. So I'm going to put -5 in for y, and I'm going to put 2 in for x. And now I should be able to solve this for b. Okay, so let's see. Just going to leave that alone. 3 times 2 would be 6, so I get 6 over 2. And 6 over 2 is 3. Okay, and then I'm just going to subtract 3 from both sides. And I've got that the b value is -8. Okay, and now I can finally finish the problem. I can write my equation. Okay, so let's remember our equation. We were writing it in slope-intercept form. So I really just need these two pieces of information, and I have them, right? I found both of them already. Whoops, I'm off screen a little bit. Sorry. So I need those two pieces of information, and I have figured them out already. So I meant these two pieces. Sorry, I didn't mean to underline that. I need the slope, which was 3/2, so that's going to go in here. And then I need the y-intercept, which is going to be -8. And there is my equation, and it's in the right format. Okay. All right, so I'm going to do another problem that's similar. This one's a little different. First off, the given line is not in slope-intercept form, so there's going to be a little bit more work involved there. Also, these two lines are perpendicular, not parallel. Okay, so just be on the lookout for that. So let's set this up in the same way. Got my old and new lines. This time they're going to be perpendicular to each other. Okay, I'm just going to write the equation of the old line. And I'm always going to need the slope of this. Okay, I can't see the slope right now, but hey, I can rewrite this in y equals mx plus b form. So let's go ahead and do that. I'm going to subtract 2x from both sides. And I'm going to put the negative 2x in front of the 6, right? You could write 6 minus 2x, but I'm trying to get it in y equals mx plus b form. So now it's pretty close. I got the y and the x and the constant in the right positions. But I don't want, it's not 3y equals mx plus b form, it's just y equals mx plus b form, right? So I want to get rid of that 3 there. So what I can do, I can divide the whole equation by 3. So that's going to give me y equals negative 2/3 x plus 2. 6 over 3 is 2, okay? And the only thing I really care about here is the slope. And now I can see that the slope is negative 2/3. Okay. All right, so that was all my old line there. Put that a little close together. But now I can use this slope to find the slope of the new line. Some people are going to say, oh, it's negative 2/3. Well, that if they're parallel, that would be the case. But now I need the opposite reciprocal of negative 2/3. So opposite, so that means it's going to be positive, and the reciprocal, flipping it like so. Okay. And then I've got a through point as well. Okay, so when I'm writing the equation in slope-intercept form, I need the slope. That's done, right? The other part I need is the intercept. I need the b. So I'm going to go ahead and try to find the b. Okay, so I'm starting with this. And now I can substitute in, I know that's going to have a slope of 3/2. Okay. And I'm going to substitute in this xy pair. So y is negative 3, and x is going to be 2. And then I can solve this for b. Okay. So this would give me 6 over 2, which would reduce to 3. But also, you know, you're multiplying by 2 and then dividing by 2. So 2 over 2 equals 1. Those are just going to cancel each other out. So that's another way you can think of that there. Okay, and then I'm subtracting 3 from both sides. Okay, and there's the other important piece of information. So these two pieces are what I need to write my equation. Right, I'm just going to put those two pieces of info in those two slots. And there is our equation in slope-intercept form. Okay. All right, let's move on to the next page. Okay, got another similar question here. So again, we're going for slope-intercept form. So yeah, if you want to pause this, this is actually just different numbers, same kind of deal as the last problem. You can try it out on your own. I'm just going to get to it. You can see these are perpendicular. My old line is 3x minus 4y equals 12. And I don't know equation for the new line yet, but I'll get there. Okay, so I'm going to, I want this in y equals mx plus b form, so I'm going to subtract 3x, and I'm going to slip that in front of the 12. So I've got negative 3x plus 12 then. And then I'm going to divide the whole equation by negative 4. Okay, a negative divided by a negative would be positive. And then 12 divided by negative 4 would be negative 3. And the only thing I really care about here is the slope. Okay, so now I can find the slope of my new line. It's going to be the opposite reciprocal since these are perpendicular. Okay, and I've also got the through point. So now I'm going to use this slope and this through point. The slope. The slope is one of my important pieces of info, but I still need the y-intercept, right? So I'm going to use these two pieces of information together to find b. Okay, so I'm going to substitute in -4/3 for the slope. Y is going to be -1, and my x value is 3. Okay, and this kind of works out nicely again because those 3's are going to cancel each other out. And then all I have to do is add 4 to both sides to find b. Okay, and I've got my second important piece of info, and now I can write the equation. Okay, so slope was -4/3, and b is 3. And there we go. Oh, off screen again. There we go. Okay, and then our next topic here is directed line segments. Okay, and it's going to be a little bit more challenging, I think, but we'll see. So a directed line segment represents movement. There's a direction, right? That's why it has the word direct. It's not just a line segment, it has a direction as well. Okay, so the easiest way to explain this is with an example. We're going to find the coordinates of point P along segment AB so that AP to B to PB is in the given ratio. Okay, and this is supposed to be, this got cut off on my printer here, but that's supposed to be point B there. Okay, all right, so we're given the coordinates of these 2 points, so I'm going to go ahead and just plot my line segment here just to get a visualization. So here's point A, it's -2, 1, and point B is at 4, 5, somewhere up there. You can just freehand this, but I'm just trying to get a straight line here. Okay, so there's my segment. All right, and we want this in a 3:7 ratio. What that means is that we're going to split AB into 2 parts, like I've got over here. Okay, and 3:7. So the first piece would be A to P. So if this is 3 units, then this is 7 units, okay? Which means that the whole thing is going to have a length of 10 units, okay? So somewhere in here, I want to split this into about 3/10 of the line segment's going to be over there, and 7/10. So I'm thinking it's going to be somewhere pretty near the y-axis to kind of just split it visually, sort of like that one, okay? So just to give you an idea of what we're actually doing. Okay, so point P, if you're thinking about this as a directed line segment, it's really important that that in a directed line segment, this is the start. The first letter is the start. So we're going from A to B here. If it was directed line segment BA, then we'd be going in the opposite direction, okay? But that means this is my start, okay? And that means that P is going to be 3/10 of the way from A to B. It's not 3/7 of the way. That's a mistake that I see a lot. But you got to think, well, it's gone 3 of the total 10 sections, okay? So this is 3/10 of the way. I don't know why I put the THS, but 3/10 of the way from A to B. Okay? It's not like you have to write that down every time, but you just need to understand it in order to do the problem. Okay? All right. So the way I like to do this is with kind of splitting it into horizontal and vertical distances. Okay. Um, so what I can do, I can find the horizontal distance from A to B. Okay. By that I mean if I put a little dashed line down here, well, it's going to end right there. The horizontal distance is just the left-right distance, right, from A to B. So it would be this distance, which I can find really easy looking at this. I've got 2 units and then another 4 units, so that's going to be 6 units total, right? You could also just look at, if we didn't have a picture, we could just look at the x-coordinates. I started 2 to the left of the x-axis, I ended 4 to the right of the x-axis. And if you even want to go back and use the ruler postulate from the first or second section in the book, you can just take the absolute value and subtract the x's. It's the difference in the x values, right? So I could do 4 minus negative 2, or you could do negative 2 minus 4. It doesn't really matter, because when we have absolute value, it's going to come out the same either way. So it's going to be 6 units, right? That's 6 units down there across. I'll put it down here so it's not in the way. Okay. All right. And then what we can do, if I'm going A to P, well, it's going to be 3/10 of the way across this, but that means it's going to be 3/10 of the horizontal distance. So now I can find 3/10 of 6. I can find out how far across this line segment it's going to be. I need to take 3/10 of 6. All right, and mathematically, if I want to do that, 3/10 of 6, well, I can just take 3/10 and multiply it by 6, okay? And that's going to give me 18 over 10, and I could reduce that. But really, it's going to make more sense to write this as a decimal in this case. And when we get to the end of the problem, so 18 divided by 10 would be 1.8. I mean, you could put it in a calculator too, but it'll come out to 1.8, okay? So now I have an idea, oh, it's going to be P is going to be 1.8 units, so it's not going to quite get to the y-axis here. It's going to be like just somewhere in there, right? It's going to be 1.8 units to the right of point A. Okay, and we're going to do the same kind of thing now with the vertical distances. So the vertical distance between A and B would be this distance. I mean, you could put it over here too. It doesn't really matter, right? But it's the difference in height of the 2 points. So in this case, we'd be looking at the difference of the y values, okay? Or, I mean, if you have the graph, you can just count, but you could also just subtract your y values. So 5 minus 1, and I'm putting in an absolute value because if you did 1 minus 5, then you'd end up with negative 4, which isn't the distance. But with the absolute value, it'll come out to positive 4, okay? And then I'm thinking that this is, okay, this is going to be 3/10 of 4, right? I know that's 4 units, and I need 3/10 of 4, so let's find that. 3/10 of 4 is going to be 12/10. Okay, and yeah, I could reduce that. It would be 6/5 reduced, but as a decimal, it's going to come out to exactly 1.2. Okay. So, you know, I'm going to go 1.2 up from here. So I'm just visually, it's going to be, and it's not, the graph is not really that important. This is just to visualize what's going on, okay? So in future problems, you don't necessarily have to draw a graph. But I was just trying to show, you know, we're going to go from here 1.8 units to the right, we found, and then 1.2 units up. So now we can actually find the coordinates because I can think, oh, starting from point A, I can add 1.8 to the x value, and I can add 1.2 to the y value. And that's what I'm going to do here, okay? So I've got this set up for point P already, which is, this is going to be point P here, right? So I put in just my original x and y coordinate, right? This is my original x. And I'm using the x where I started, using the x from point A, not point B, because this is directed line segment AB, not BA. Okay, and this is my original y. Okay, and then I was adding the 1.8 to that, That was like the 3/10 of the horizontal distance, right? And then I'm adding the 3/10 of the vertical distance, which is 1.2. And now I just do my addition and clean that up a little bit. And that's going to come out to negative 0.2 and 2.2. And that is the coordinates of point P. That's what I was looking for. Okay. All right, those can be a little bit involved. Let's try another on the next page. I'm going to just skip the graph. I was just doing that to try to explain what's happening. So I'm just going to do kind of this part of it on the next problem. So you can pause it and try it out on your own if you like. I'll get right into it. Okay. So A to B, we're talking about the horizontal distances here. So I'm looking at the distance from 1 to 8. Okay, so the distance from 1 to 8 is 7. So you don't have to write out that calculation if you just want to do that in your head. Okay, and then I'm thinking 4 to 1. So a lot of people are going to say, oh, I'll take 4/1 of 7. Well, that doesn't make sense. That would be 28, right? So I said I wasn't going to draw this out, but I lied. I am. So here's segment AB, and then P is going to be somewhere along there. Okay, and it's a 4 to 1 ratio, so that means we're going to go 4 units in that first bit and 1 unit in the second bit. So it has a total length of 5 units. So this is going to be 4/5 of the way, right, from A to B. So that means I want to take 4/5 of 7 when I'm looking at the horizontal distance. That's going to give me 28 over 5. And if you put that into a calculator, you'll get 5.6 as a decimal. Okay. All right, and now let's look at the vertical distances. Okay, so I'm going to subtract my y's. Okay, so that's just a distance of 1, and I want to take 4/5 of that. So 4/5 of 1 is 4/5, and that's 0.8. Okay, and now I've got the horizontal bit that I've got to add, which is 5.6, and I've got the vertical bit that I need to add, 0.8. That's going to give me 6.6 and 3.8. Okay. All right, let's try one more. Okay, and yeah, I'm just going to draw the line segment picture just to organize things. Okay, so my ratio here is 3 to 2, so that first bit would be about 3, and the second bit would be 2, so I put P a little closer to B than it is to A, and so the whole line segment is going to have a length of 5. Okay, so that means I'm thinking of this as 3/5 of the way from A to B. All right, so distance from A to B, my original points, I can see it's going to be 5, right? It's going from 2 to 7. And just to be cool, I'm going to use the ruler postulate. And there we go. Okay, and then I'm going to take 3/5 of that, 3/5 of 5. And so, hey, those 5s are going to cancel, right? So this is going to come, I mean, it'd be 15 over 5, but it's going to come out to exactly 3 there. Okay, and then our vertical distances, we're looking at the y's. So I know that's going to be 2 units, but again, just to be cool, I'm going to use the ruler postulate. Okay, and then I'm going to take 3/5 of 2. These actually go quick once you get used to them. It's just understanding what is happening and getting used to the process. So that's 6/5, which is going to be 1.2. All right, there's a little bit of a trick to this one that didn't really happen in the 2 previous problems. Okay, so I'm starting at 2 from my original x value. And then I know my horizontal distance, it's going to be a difference of 3. So I'm going to add 3 to that. Now, you got to be careful here. Going from 2 to 7, it's increasing. Okay, so I need this value here after I do the adding to be between 2 and 7, because it's going to be 3/5 of the way from 2 to 7. So this would make sense to add 3 here, and then that's going to come out to 5, right? But let's take a look at this. So for my y's, if I add 1.2 here, okay, I'm putting that in pencil because I'm going to erase it in a second because it's wrong. But if I add 3 and 1.2, I'm going to end up with 4.2. Now let's think about that. Is 4.2 in between 3 and 1? Would it be 3/5 of the way from 3 to 1? No way. It's not between 3 and 1 on the number line, right? 4.2. And that's because this is decreasing when you're looking at the y's. Okay, so it's very easy to make this mistake, and this is always a point of confusion. But if you're looking at the y's, I still want to move 1.2 units, but I don't want to add 1.2 since this is going down when I'm looking at the y's. So I actually want to subtract 1.2 here. Okay, so actually I won't erase this, but I'm going to write in. I'm going to actually subtract 1.2 there. So you can also write that as adding a negative in. Okay. So that means that this is incorrect here because that's not between those two y values. But if I do 3 minus 1.2, then that's going to put me at 1.8. And that is the correct answer. Okay? So the most common wrong answer I get on this problem is 5 and 4.2 rather than 5 and 1.8. You got to think, are your x's increasing or are they decreasing? And the same thing with the y's. In this case, the y's are decreasing, so I had to subtract that 3/5 value rather than adding it. Okay. Okay, this is a big section, and there's one more topic, and that's finding the distance, I should say, from a point to a line. And we've actually found the distance from a point to a line before, but in those problems that we've seen, we already had them graphed on a coordinate plane, and they already had, you could tell what it's much easier when there's a graph and you can see what the distance would be. So first off, you have to understand that the distance is going to be the perpendicular distance, right? That's the shortest distance. So it's the perpendicular distance. Okay, so in those graph problems, you could already see a line segment that was perpendicular, and you could see where the intersection is, and then you just use the distance formula. But this is a little bit more involved because we don't have a coordinate grid, and I don't have a point here where a perpendicular segment would meet. Okay, so we've got, what we do have is the coordinates. So this is the point -1, 6. And then I've got the equation of a line. So I'm just drawing a little graph here just to organize our thinking a little bit. Okay. So, hey, what I'm looking for is going to be the length of a line segment, something like that. Okay. That's what I'm going to be looking for, that red piece. Okay. So, here's the 3 steps. I'm going to write an equation for the distance line. So the distance line, well, this is a segment that I've got here in red, but we could extend that into a line. So when I say write an equation for the distance line, I mean that line, not that line segment. Okay? So let's go ahead and do that to begin with. So I can think, well, hey, I've got an old line and a new line, right? My old line is going to be this original one that was given, y equals -2x, and I know that's going to be perpendicular to the equation of my new line, which is going to be the red one, the distance line. Okay, so hey, I can already see here the slope is -2. I know they're perpendicular slopes, so I'm going to use the opposite reciprocal of -2. Remember, you can think of this as -2 over 1, right? So the opposite reciprocal of that would be +1/2. Okay. And then for a through point for this line, well, I've got point P. Okay, So now I'm in business here, okay? Now I'm going to write this in slope-intercept form. So let's go ahead and find, we've got the slope part, we just need the intercept part. So I'm going to now find b, okay? So I'm going to substitute into y equals mx plus b. I'm going to use these two pieces of info. So I'm going to put in my y is going to be 6, my slope is 1/2, my x is -1, and then I should be able, to solve for b here. Okay, so let's see. This is going to simplify to that, and then I'm going to add 1/2 to both sides of this. Okay, so I could write 6 plus 1/2, but I don't want to write 6 and 1/2. That's kind of I mean, it's not incorrect, but I want to write this as an improper fraction. So what I'm going to do is change the 6 into 12/2. Okay, then when I add 1/2 to both sides, I've already got a common denominator. So this is going to come out to 13/2. Okay, and so got my second piece of info here, and now I can write my equation. In this format, I'm going to get y equals, off screen again, y equals positive 1/2 x plus 13/2. Okay, step 1 complete. So we've got an equation now for this red line. So I'm going to put this into this picture I have up here just to visualize what is happening. So this was y equals 1/2 x plus 13/2. Okay, so in order to find the length of this line segment, I need to find the coordinates of that point. Okay, now I can do that now because I've got two lines that intersect at that point, and I know the equations of both of those lines. Okay, so what we can do is we can set up a system. We're going to solve a system of equations. Okay, so first I'm just going to write those two equations up here. Okay, so how am I going to solve this system of equations? Well, you've got two different options, really. We've got substitution or elimination. Elimination is sometimes called the addition method or subtraction method. I'm going to use substitution here. This kind of lends itself to it really well because I've got y equals this and y also equals this. So I could use substitution, or actually the transitive property would work here too. Y is equal to two different things, so those two different things are going to be equal to each other. So I can say then that -2x equals 1/2 x plus 13/2. Okay, so now I've got one equation with just one variable, and I should be able to solve this for x. Okay, so I want to get those x terms on the same side and combine them. Now you can just add 1/2 x to both sides, or sorry, subtract it, or you could add 2x to both sides. But what I would like to do personally is to clear the fractions. I think this is just going to be a lot easier without the fractions. So I'm noticing, hey, both of those have denominators of 2. So what if I just take the entire equation and double it? Okay? And you can do that as long as you multiply the whole left side and the right side by the same thing, because that's just the multiplication property of equality, right? So 1/2 x times 2 is 1x, and 13/2 times 2 would be 13. And then that's a much nicer equation to work with. So I'm going to subtract x from both sides here, and then divide by -5. Okay, so my x value is -13/5. Okay, but I'm not finished here yet. Because I still need to find the y that goes with this. And what I can do now is go back to one of my original equations. I could use either one, but I'd much rather use that first one. It's just simpler, right? So now I'm going to take this and substitute it into y equals -2x. I'm going to put it in for the x, right? Y equals -2 times -13/5. All right, a negative times a negative is going to come out positive. 2 times 13 is 26. So I've got 26/5 for my y value. Okay? So it's not pretty, but it doesn't have to be pretty. So my intersection here is going to be the point -13/5. Off screen again. -13/5, 26/5. Okay? So just to make it easier to put in the little picture up there, it doesn't really matter, but I'm going to rewrite that as a decimal. So that's going to come out to -2.6 and +5.2. Okay? All right, and I can't zoom out far enough to get the whole thing on the screen, but I'm going to take this point and just put it into the little picture I had up there. So now I've got -2.6, 5.2. Okay, so now I can find the length of that line segment because I've got the endpoints of the line segment. Okay, so got the distance formula here. Right, I promised it's not going away anytime soon. Sorry, I'll keep that picture up for a second. I'm going to subtract the x's. I've got -1 minus -2.6 squared, and then I'm going to subtract the y, so 6 minus 5.2. And you could subtract in either direction as long as you're consistent with which way you're subtracting. Okay. I'll put this back down here so you can see that if you're still getting it. Okay. So -1 plus 2.6 with my double negative would give me 1.6. And then 6 minus 5.2 would be 0.8. Okay, and then I'm going to square both of those. So 1.6 squared is 2.56, and 0.8 squared is 0. Sorry about that. All right, and then I'm going to add those two together. It's going to come out to 3.2. So I've got the square root of 3.2. And then that's going to come out to roughly 1.79. It goes on much longer than that. I'm rounding to the nearest hundredth here. Okay. And there we did it. So it is an involved process. Yeah, it's one of the longer types of problems. You got to pull in some of your geometry skills and also some of your algebra skills. So there it is. See you next time.